to this meeting of the International Association of Software Architects in Israel. I think many of you have participated in our previous meetings, so welcome back. And today we have a special guest, Professor Kazman, came from Hawaii, and he's a person with a vast experience in the field of software architecture, has published many papers and also a few books. So I'm sure you have a lot to enjoy in this talk. I would like to thank LivePerson for hosting us, for providing us the place for this meeting, and also food and drinks. So thank you. And I would like to thank a few people who have contributed especially to organize this meeting. So Daniel Gross and Dima Halatov and Michael Khalida, who is not here. So we in the International Association of Software Architects will continue to try to organize these meetings. I invite all of you, if you are not still members of our LinkedIn group, please join. So you'll be able to receive notifications each time we organize such a meeting. And we are always open to people who want to contribute, if you want to help us organize a meeting, if you want to speak, if you would like to speak in a meeting, if you have some interesting subject you would like to talk about, let us know. Okay? So, and Michael from LivePerson would like to say a few words also. Thank you.
Yeah, I would just like to plug a few words about LivePerson. LivePerson is an international company, an American company. R&D is in Israel, and you're sitting in one of the conference rooms. We have 3 stories here, about 400 people in Israel, and a young company doing lots of stuff with software development for web. Our main focus in LivePerson is around engagement or more advanced engagement for many companies in the world. Main product is the chat that you might encounter when you go, for instance, to Apple or stuff like that. But behind that, we have a lot of technologies, getting a lot of data into the systems and doing very advanced stuff with it. So we're doing very interesting stuff in LivePerson, and we're always interested in good people. So if you're interested, come talk to me after the talk, and have a good evening. Thank you.
Okay, thank you for inviting me and for hosting me. So the talk that I'm going to be giving today is a little bit atypical in that it's not all about architecture. There's an architecture component to it, so if you came here to hear about architecture, you won't be completely disappointed. But actually what I'm going to talk about is a new model of system development which breaks many of the rules that we have held dear for decades. It breaks many of the things that I teach my students when I teach them software engineering. And I think it's something that we all are going to have to come to grips with over the next few years. And I call this the Metropolis model. So my thinking about this arose in consideration of 2 trends that I believe are transforming the world. And one is the rise of something that has been called the socio-technical ecosystem. Ecosystem that we're all part of, which is technical in nature, but more fundamentally is about people and their relationships. And the other trend is the business trend towards service orientation. So there's a really intriguing book written by Yochai Benkler, who's a law professor at Yale. And but he writes a lot about technology and technology trends and how technology is changing society. And he wrote this book, The Wealth of Networks, which is a play, of course, on Adam Smith's The Wealth of Nations. And he was really looking at a number of phenomena, but most important was the open source phenomena, the open source and open content phenomenon. And Benkler calls this a radical transformation of how we create our information environment. It's changing the notion of production in our society and changing the models, essentially the traditional capitalist profit-based models upon which much of production was based for centuries. And Benkler calls this commons-based pure production. A commons is like a public park. It's something that nobody owns and everybody shares. Peer production is production by peers. People who are not in a strict hierarchy, they don't control each other, they can't order each other. Open source and open content are two examples of peer production, and they have transformed the world. Many open source products are the leaders in their technology areas. So you think of the Apache web server, or Firefox, or Chrome browsers. You can think of the Android operating system, MySQL database. The list goes on and on and on of the open source products that are important, or in some cases dominating their particular technology area. And then think about open content systems. Think about Wikipedia, far and away the largest encyclopedia in the world, and the hundreds, thousands, tens of thousands of other examples of open content. Twitter, Flickr, the Blogspot, so many open content repositories out there which are creating new forms of products and new forms of knowledge. Simultaneous with this rise of the network, as Benkler calls it, is the rise in the importance of services. We are a service-oriented economy, right? Everyone in this room is in the service business. Service industries account for a little more than 55% of all economic activity in the United States, which means that as a society, we have transformed from a goods-dominant view of how we create value, where we create things that we sell to one another, growing food, making shoes, whatever, to creating services that we sell to one another. This has transformed many industries. So one of my favorite examples is IBM. IBM is the most patent-productive company in the world. And it now earns more money, by far, from its service-based activities than it does from all of its intellectual property put together. So, in a service-oriented view, something that's called service-dominant logic, customers are seen as co-creators of value. So value in a goods-dominant view of the world came from a company, from an organization, and was pushed out to customers. In a service-dominant view of the world, customers are co-creators of value. And this is a key distinction. So, this is more than just a shift from goods to services. Yes, it's a shift from goods to services, but I think it's more than that. I think it changes the role of the enterprise. It changes what it means to be an enterprise, what it means to create value in this new economy. And this is creating new phenomena in projects, and I'll talk about some of these. What does it mean for software engineering? Now getting back to more familiar ground. What it means is that everything that I teach my undergraduates when I teach them Introduction to Software Engineering is wrong. Everything that I teach them, almost everything, is broken in this crowdsourced world. So we teach, for example, that software is developed by teams in projects, and that there are project managers, and that managers can manage these projects. And you should build Gantt charts and work breakdown structures, and you should allocate tasks, and you should collect requirements and make sure those requirements are complete and consistent, and that we can develop and test software in planned increments that we call releases. Any of these words sound familiar? This is the standard canon of software engineering and has been for several decades. And of course, we teach that system growth is sublinear. This is one of layman's laws of software evolution, that every system will grow quickly at the beginning and eventually will start to get weighed down by the weight of its own infrastructure and its code base and the increasing complexity, so that improvements to the software, additions to the software, start to get harder and harder to add. That n plus first line of code is harder than the nth line of code. And so system growth always goes sublinear after a while. That's a law, right? The law of software evolution. And I'm saying that, in fact, in this crowdsourced world, all of these laws are broken. So I believe that to take advantage of this, if this is really an important trend, and I think it's an important trend, whether you like it or not, whether you see profit in it or not, it's an important trend. We need a new model of software development and the software life cycle. And we need something that helps us think about creating software and creating content that is open, commons-based, pure production. And if you look at the list of just a few of the companies that have that as their basic business model, you'll see that there's quite a few companies, and they're doing quite well with this model of value creation. If you go to a site like Alexa.com, which tracks the top 10 websites in the world, you look at the top 10 websites in the world, you'll see that I think right now 4 out of the 10 are open content sites. They're YouTube, Facebook, Blogspot, and I think Wikipedia. And I think 5 out of the 10 are search engines, which don't actually sell anything. They're just providing you a quick way to find the other stuff. There's only one site in the top 10 websites in the world that actually sells something, and that's Amazon, at least as of this month. So what are the characteristics of this new model? I think there are 8 characteristics, and I'm going to walk you through each of them because they have funny names that I made up. So the first funny name that I made up, well, this is really the only funny name that I made up, is called mashability. In the old way of developing systems, we made systems hard to tear apart. We did this sometimes for reasons of intellectual property. We didn't want people to be able to reverse engineer our systems. We did this sometimes for reasons of security. We did it sometimes just historically because that's the way we built systems. In the new model of the world, mashability, taken from this idea of a mashup, is a core capability. It's a core capability in commons-based pure production. So mashups are an accepted practice. Open source software always builds on other open source software. The Apache Foundation created a special project called Maven just to keep track of dependencies between other open source projects. Because there are transitive dependencies that you need to worry about when you're building on top of the thing that someone else built on top of the thing that someone else built. Web services APIs are proliferating, making mashups easier to do. It's common practice now that you don't build it yourself. At least you don't build all of it yourself. And Google Maps was, I think, the first publicly, widely disseminated API. And they only got the idea after people started reverse engineering their protocol and building mashups using Google Maps. And once they saw people doing this, they decided, maybe we can make this a little easier, and started publishing their APIs. In general, open source projects encourage this. Open source projects can encourage this because they are non-rival. So non-rival is a term from economics. It doesn't mean that you don't have competition in open source projects. What non-rival means in economic terms is a good is non-rival if when I have some, you don't have any less. So an apple is rival, because if I eat it, you can't eat it. But Firefox is non-rival. I can have a copy, you can have a copy, any number of people can have a copy. None of us are diminished by this sharing. And this is a key difference in open source products. Another distinction is in terms of requirements. In our old software project models, we accepted that requirements change. But in any given iteration, we try and collect and analyze those requirements. Even in Agile projects, you still say, okay, this is the set of user stories we're going to worry about in the next sprint. In this new world, requirements in peer-produced systems simply emerge from the crowds. They emerge from the collective ideas, from the collective initiative of the peers. There is no notion of coherent requirements. There is no notion of making requirements consistent, complete, non-overlapping. They will inevitably conflict. If you look at apps built on the Android platform or plugins for Firefox or Chrome, you'll see lots and lots of replication, duplication. It's very similar apps covering very similar requirements. Who would build anything that way in a rational requirements process? So clearly this is something different. And so you can never really know the requirements in any global sense, and we have to simply accept this. Another thing is that these Metropolis projects continuously evolve. So the old way of doing things, we said that systems evolved in planned releases. We have a release planning cycle. We have a release cycle. We announce them. We patch them, and so forth. In the new way of doing things, systems are constantly changing. There's no notion of a stable system state. So parts of a peer-produced system are being torn down, changed, rebuilt, refactored constantly. And you can't think of a release of these systems any more than you can think of a release of Tel Aviv. It's constantly changing, it's fluidly changing. Another change, focus on operations. What I teach my students, what most people in software engineering teach, is how to build systems and, if the students are really lucky, how to maintain them. They might get a bit of instruction on maintenance, even though that's mostly what most of them are going to do when they graduate. But in this new world, there's a new core competency that's required, and that's operations, something even beyond maintenance. So if you think of Google, Amazon, they're like public utilities. They're like the water or electricity. They're always on. 24/7, 365. And this implies ultra-high availability. It implies scalability. It implies the ability to evolve seamlessly without bound. A new, successful Facebook application gets about 300,000 to 400,000 new users a day. If you did not build that app with scalability in mind, you're going to be out of business in a day and a half, or maybe half a day. Right? So this is simply a core competency. Can't be ignored. In the old way of doing things, we taught that there was something called the project team. And the project team had members, and the members had roles. And these members worked from a set of requirements along a planned path. The new way of doing things, everybody's a volunteer. Teams are diverse. The members of the teams work on whatever they like to work on. So Linus Torvalds has said publicly many times he cannot order anyone to write a single line of code for the Linux kernel. He can write it himself, of course, but he has no managerial sway over what anyone does. Peter Drucker in the 1950s already said that you have to lead knowledge workers. You don't command knowledge workers. That even 50 years ago, that model of management was already changing, but it's come to an extreme now where you don't even have the threat of firing someone, because how can you fire a volunteer? Another thing that we used to teach is that software, requirements for the software and the software itself could be determined to be complete, correct, consistent. You could achieve this with techniques like requirements analysis, with testing. In the new world, perpetual beta is more the norm. So think about something like collaborative tagging. If you go to Flickr and you want to look at a word cloud and find pictures based on some keywords, who determines what the right keyword is for a photo? And the answer is, we all do, collectively. There isn't a master editor at work, just as there's no master editor in Wikipedia. Wikipedia doesn't claim to be complete or correct, but if you look at a couple studies that have compared, that have assessed the accuracy of Wikipedia articles, they found it to be roughly equivalent to Encyclopedia Britannica. So despite the lack of formal authority, despite the lack of top-down management, this bottom-up Darwinian soup seems to have been able to achieve feats that rival those of highly trained professional editors. Another thing that we did in the old way of doing things is we assigned resources to projects. And resources were there for the project manager to manage. Deployments were planned, releases were planned. In the new way of doing things, peer-produced applications are subject to the whims of the peers. And this kind of works if you have enough peers. So think about Skype as an example of a peer-to-peer network, not peer-to-peer production, but a peer-to-peer network. Skype produces comparable quality, not quite as high, but comparable quality to the traditional telephone network. And it does this despite the fact that no peer in the network is guaranteed to be there for very long. If you get a large enough pool of unstable resources, the aggregate becomes stable. What's the name of the Berkeley volunteer computing project? Pardon me?
Distributed.net?
No, it's a distributed supercomputer, grid computer. I'm blanking on the name of the project. But again, that distributed grid computer has been consistently ranked in the top 10 most powerful supercomputers in the world, even though it's entirely based on volunteer computation. People running their Berkeley project screensaver on their computer.
Are you talking about SETI?
SETI, yeah, SETI at home. Thank you. Asleep. Okay. And finally, the final characteristic of these Metropolis projects is emergent behaviors. In the past, what we wanted was deterministic behaviors. We knew when we did input A, we would get output B. But in the New World Order, emergent behavior is normal, and in some cases even desirable. And so many systems have seen behaviors that went far beyond the vision, far beyond the intent of their creators. And we've seen this in all kinds of open content systems. So my claim is that we need a new logic for developing systems in this commons-based, peer-produced world. So a logic is a set of principles, the way to reason. And the old models and their principles, I'm claiming, are inadequate for this new form of production. And this new form of production appears to be important and gaining in importance, not something that you can ignore. So what are the principles on which we can build a new model? So the Metropolis model has this as a kind of organizing concept. This isn't an architecture, but wait a second and you'll see how it relates to architecture. So in the middle, you've got a kernel. Around that you have a periphery, and around that you have the masses. So in an open source project, this does look a lot like architecture. The kernel is a set of core functionality, a platform. In the case of Linux, they call it a kernel. In the case of Facebook, they call it their application platform. In the case of Google Chrome, it's an API or a set of APIs, toolkit. And surrounding this, there are a set of developers. Developers surrounding a kernel? Well, the kernel is actually a group of people. These are the core committers in an open source project. And surrounding the committers are a set of contributors, developers who can make patches, contributions to the project, and the core team determines whether those go into the open source body or not. They're the gatekeepers. They're the ones who control the conceptual integrity. And around this are the masses, the users. Now I've shown a dashed line between them. A user can make a contribution and become a developer at any time. The source is open. A developer may, given enough accomplishment, when they have achieved enough status, according to the other committers, may be promoted to the rank of a committer. If you look at open content systems, a kernel is something like Wikipedia's wiki. It's the fabric that holds the wiki together. At the periphery are the prosumers, the producers and consumers of content, the ones who create encyclopedia entries, and again, the masses are the customers. So this same model describes a structure of relationships between core structures and core communities, a team around them which is much, much larger, orders of magnitude larger, which are contributors, and around those, again, much, much larger, orders of magnitude bigger, are the masses, the people who are the end users of these products. So that's just a way to think about this, but you'll see that will have implications for architecture and for many other things. So what are the principles upon which we can build this new model? 7 principles. which I'll talk about. They don't have quite such funny names. First is egalitarian management. Open source and open content projects are not top-down. Linus Torvalds can't order anyone to do anything. Wikipedia cannot. Jimmy Wales cannot tell anyone to create a particular Wikipedia article, or not create it, or change it, or not create it. So work is not assigned. People choose what they want to work on, when they want to work on it. And status and rights are earned. So to become a Wikipedia editor, or a super editor, I forget what they call them, you have to have shown enough contributions over a consistent period of time. You have to be voted in by your peers. And this is true on many open content sites, that it's a pseudo-democratic process for getting you in. I say pseudo because the rules of the democracy vary from project to project. Some projects you have to be unanimously approved, and others it's a simple majority, and so forth. But there's some voting procedure by which you can earn status and rights. Requirements are bifurcated in this world into kernel requirements, kernel service requirements, and the kernel requirements deliver little or no end-user value. So if you think about an operating system kernel is just there to manage resources. The end-user value comes from all the applications that run on top of the kernel. A wiki with no content delivers no end-user value. It's all of the encyclopedia articles that are written on top of that wiki that deliver the end-user value. So the kernel delivers your quality attributes. That's what determines the system's availability, security, performance, and so forth. Usability, absolutely. These tend to be slow to change. The basic structure of Wikipedia, the wiki underneath Wikipedia, does not change very often, even though there's a firestorm of changes going on every day in the actual content. The periphery requirements are contributed by the peers. This delivers the majority of the function, the majority of the end-user value. Think of all the apps that run on your smartphone. That's the reason why so many people love their smartphones or their iPads, is the apps. And this is what gives you the value, and these are rapidly changing. Right? There's hardly a day that goes by when I don't have an update of some app for something on my Android phone. The architecture, we finally got to architecture, therefore has to be similarly bifurcated. There's a kernel architecture, and that kernel architecture looks a lot like a traditional architecture, like the kind of thing that I actually teach. And that's developed by a small, coherent team in an open source project. This is the committers, with a high focus on modularity. So if you look at the success of Linux, the fact that Linux has been able to exhibit superlinear growth in defiance of layman's second law of software evolution, the way that it did that was by being highly modular, to allow an enormous amount of simultaneous, parallel activity by the periphery. And their collective contributions have resulted in superlinear growth in Linux, even though by any measure it should be dying under its own weight by now. So the kernel infrastructure is designed by this small coherent team, designed with modularity in mind, and it provides the foundation for the achievement of all of the system quality attributes. And the peripheral services are built on top of the kernel, think of it as a platform, and are otherwise unspecified. They use the services of the kernel, they build on it. If you want to build a new Facebook app, you could use the Facebook application platform, but what do you want to make that app do? That's completely up to you. The majority of implementation is crowdsourced to the world. People are doing it at their own delight, at their own pace, using their own tools, with their own standards. And the implementers of the kernel are close-knit. As I said, they're the gatekeepers. They're the keepers of the architecture. So there are really these two distinct populations of implementers. What about testing? These systems tend to be pretty reliable. How do they achieve that, given this seemingly chaotic structure? Well, the kernel has to be highly reliable, and this is tractable because of the many eyes phenomenon. The kernel is used by everyone, by every app. And so it is constantly being exercised. As I said, it is relatively slow to change. And the periphery, nothing depends on it being correct, which is why it can be in perpetual beta all the time. Sufficient correctness is the norm. If you don't like the app, if it's not reliable, toss it out and get another one. The important thing here is that a failure of the app will not cause a failure of the system. What about delivery and maintenance? Well, the kernel itself has to be stable. It changes relatively slowly compared to the pace of change of the periphery. And when it does, it is almost always backward compatible. And this backward compatibility will allow the next property, which is ubiquitous operations. And at the periphery, it's perpetual beta. Constant stream of uncoordinated releases, no notion of a stable system state, no notion of a release of anything but the kernel. And finally, ubiquitous operations. So traditional systems, even ones that had high reliability requirements, could be taken down occasionally for upgrades, for example. But Metropolis systems are always on. Upgrades are done in a manner that does not interrupt service. They're rolling upgrades. They're not all or nothing. Which means that systems have to tolerate multiple versions operating at the same time. They have to be backwards compatible with earlier versions. They have to be resilient in the face of differences or errors in protocols. Also, the systems have to scale with the number of users. And this is tractable because users tend to bring their own resources with them. Developers bring their own resources. Peers in a peer-to-peer network bring their own resources. So this is self-scaling.
Being digged.
Pardon me?
Being digged or tweeted can bring a sudden flux, so it's not only scalability. You can scale up and scale down. There's tripping.
Yeah, absolutely. So what are the implications? Why worry about this? Well, for some projects, there's no implications. I'm not saying that this model is going to dominate all software development, or that every project will be a Metropolis project eventually. Clearly not. There will always be some systems that, because of their needs for high security, because of their proprietary intellectual property, because they're safety critical systems, because of their legacy, will be built in a traditional way. Undoubtedly. I don't think I want to get on my flight back to the US and find out that we're using crowdsourced flight control software. I'll probably get back off. I'll take the next flight, thanks. So, yes, this is clearly not the model for every piece of software. However, there's a large and increasingly large class of products and services out there to which this model does apply, to which this model is salient and in some cases becoming dominant. So we've now seen example after example of open source systems which are coming to dominate their closed source competitors. Think Firefox versus Internet Explorer and Chrome versus Internet Explorer. And even closed source projects are increasingly using open source for parts of their implementation, building on top of open source infrastructure. So if this model is of interest to you, if you think that you could leverage it, as many for-profit companies have begun to leverage open source as part of their core infrastructure, core competencies. Right? We were talking about Yahoo putting more emphasis on open source. IBM, many years ago, made a strong commitment to open source. Hard to think of a big company that's completely shied away from it. So what should you do differently if you are you want to participate in this phenomenon? Well, the main implication is, again, this silly little bullseye picture. The separation of the kernel and the periphery, which has consequences on how you manage projects, how you do requirements, how you do architecture testing, V&V, delivery, operations. So for project management, a Metropolis organization implies a virtual organization. Now, many companies are virtual organizations anyway, but a Metropolis project is inherently, by its very nature, a virtual organization. And so for this project to be successful, the periphery has to be motivated. That means the project has to be more or less self-governing, self-adaptive. There has to be a minimum of bureaucracy. People have to understand where their piece fits in. So you do need a task breakdown structure, but if there's a lot of hurdles to put up to keep you from being involved, you won't be involved. There's always another project that you can spend your efforts on. And the project has to have technology for communication and coordination. So every open source project has JIRAs and wikis and email lists and blogs and a wide assortment of communication media for sharing information, for having discussions, for having debates, for coming to consensus. What's the implication on requirements? Requirements are not elicited, they're asserted. Requirements come from the developers, who are themselves intense users of the products that they're creating. They don't go out and elicit, they say, I'd kind of like to have this new feature. That would be cool. And they go build it. Or they say, this part of the code is getting kind of buggy, I'm going to go refactor it, because I feel like it. So requirements emerge through individual effort, through discussions, through the wikis. And therefore, as a management policy, you have to make those forms available. Otherwise, your project will wither. What's the implication for architecture? Kernel architecture has to be built like a traditional project, with an architect or a small architecture team that is experienced, knowledgeable, motivated, that focuses on modularity and the core quality attributes. Security, performance, whatever those are. And in doing so, especially the focus on modularity, it enables the parallel activities of the periphery. There does need to be a lead architect or a small number of leads, because these are the people who have the final say in matters affecting the kernel, in whether something gets inside the firewall or not. And they'll typically manage project coordination. So they'll take the lead in assigning priorities to JIRA items, or determining when a bug has been closed, that sort of thing. the project can guide, can incentivize, can lead implementation, but not command implementation. So this means that the leader has to be a communicator, a negotiator, an inspirer. You have to have lots of examples and tutorials to make it easier for people who are not in the next cubicle to get on board, to learn, to we all learn best by examples. And this means that you have to pay attention to usability of the kernel. The kernel has to be understandable. It has to be sufficiently simple that it's not a very steep learning curve for a new person to figure out how to use it, how to build something on top of it. As I said, in terms of testing, V&V, the kernel has to be heavily tested, heavily validated, because it's what knits everything together. But as long as you keep the kernel relatively small compared to the periphery, and you have frequent builds, and the kernel doesn't change too rapidly, which they tend not to, this is tractable. You have to have delivery mechanisms which are tolerant of incompleteness, incompatibilities, multiple versions as the norm. And again, this flies in the face of how we've traditionally built software. And finally, there has to be a focus on operations, on high reliability of the kernel, with the understanding that nothing in the periphery can be similarly relied upon. The periphery will often fail, and that cannot undermine the kernel. So, final thoughts. Lifecycle models never lead, they always follow. So, when the waterfall model was created, back in the 1960s, projects were already doing that. They were already defining increments and defining interfaces between those increments and the documentation that had to go from phase to phase. And then when people reacted to that and created the spiral model and rapid application development and later on Agile, people had already been doing it, and it took a group of people to come along and give that a name. So the Agile Manifesto did not create the Agile movement. It was a bunch of people who had already been doing Agile stuff getting together and saying, you know, we think a lot alike. Let's write down what our core principles are. Lifecycle models arise spontaneously in response to the market, in response to environmental conditions. And all I'm doing in the Metropolis model is capturing this phenomenon, documenting this phenomenon that exists, and trying to call attention to it because it's important, and if an organization wants to foster it, they need to understand it. They need to understand what's going to make it grow, make it succeed for your organization. With that, happy to take comments or questions.
So the concept of building the core and then building the applications and then building the users, I think in many ways it's actually very traditional approach to, okay, so there's an infrastructure team, they build their infrastructure, and then there's applications and there are people building on top of it. From my experience, this is something that leads into a situation that I call anonymity. So people who are building infrastructure that are super secure and super fast and super resilient to anything, they usually, and without thinking of how the applications are going to look at, building stuff that no one eventually uses. So I think the way that I kind of twist it around or spice it is, it has to be kind of vertical programming. So you do all the way from the application, from the user to the application to the kernel. at the same time. And you
So-
build it as you go, you build that kernel, and you build the application as you go. Like, let's take Facebook. So when Facebook built their infrastructure, they build their application infrastructure. At the same time, they also build the poke application, and the birthday application, and the note application.
Yep.
When MySQL built their MySQL, they build also the MySQL kernel, my ISAM database, and the DB database, and also application on top of it. So building a kernel, building applications, that's very traditional. I think the approach is very vertical today.
Yeah. So a couple comments. One is that you're absolutely right. The people who build the kernel tend to also be building the things that run on top of the kernel. And I think this keeps, and they also tend to be heavy users of the system. And I think this keeps them too busy to do the you ain't gonna need it kind of elaboration, which you would get if you were purely working on the kernel and didn't have those feet on the ground in terms of building the applications on top of the kernel. Also, this has evolved over a long time. So initially, separation between kernel and periphery in operating systems was not nearly so clean. There was a lot of layer bridging. And the clearer separation, that what I've been calling the firewall between them, is something that has evolved over decades, really, because the other way just doesn't work. It doesn't scale up. There's another comment, but now I've forgotten it because I'm jet lagged. Yeah.
Do you have examples of for-profit companies, software companies delivering products, paid products to customers or something like that with this kind of model that have to meet deadlines and timelines for projects and stuff like that work with this model? I'm not, because the for-profit, the commercial companies you mentioned, not all this were like Facebook or Google, I think. But I was wondering whether this model actually works, you just described, in for-profit companies that have to deliver products, meeting deadlines and with contracts, or maybe creating shelf projects that have timelines for delivery.
Yeah, I think there are lots and lots of examples. So think about all the open source content management systems. There are lots of companies that are building deliverables on top of Joomla and WordPress and these kinds of systems, which are themselves built as Metropolis projects.
Okay, I'll refine the question maybe. I was more referring whether, have you seen an entire project working this way? Not reusing an entire project, or I was wondering if an actual profit company works in this form of kernel developers versus periphery developers that you just described.
I know at least one of them. Confluence Wiki.
Confluence, okay.
There is a XWiki, for example, which is a completely open source company, and Confluence Wiki is closed source, but it builds a full enterprise ecosystem.
But do they internally work this way, in such a manner? I mean, is this a model?
What we want to ask, let me help you. What we want to ask is whether there are companies that deliver products to enterprises and not to end users that work with
To enterprise, this is to deliveries, yeah. I mean, more specifically, I mean, is this a model that actually works?
We work for SAP, and our whole business is to deliver those mission-critical systems to manage airports and hospitals, manufacturing systems, banks. You wouldn't want your bank accounts to be in a computer system that is perpetual data, right?
Right.
Yes, I think I know what we're always thinking. We hear the lecture and we think, where can we apply it to our world? And my feeling is that it has to change the business model of our customers before we can take these ideas and apply them to the software that we develop. And this is the part that you ignored completely, the consumers or the customers of these perpetual beta products. How do they work? What's their business model?
The customers as individuals or as companies?
No, as companies, because we deliver software to enterprises.
Also to individuals, actually.
I think this works, for example, if you take Salesforce.com, they're clearly a B2B company, and they are able to work in this model more or less because on top of their platform there are lots of applications being built and developed. So I think it's very closely related to the thing that you mentioned in the beginning of moving from a product-based to a service-based provider, for example. So SAP, as long as it's still selling products that they can, shrink wrap and send it off, it will be harder.
The question is slightly
But once you
different.
move to a software as a service model, then...
But it's not about delivering software as a service. I wonder if Salesforce.com, when they actually sell licenses for their CRM business, right, which is the regional application that they sell, do they actually develop in such a manner? Because when I buy a CRM license from Salesforce, I don't really care if it runs in the cloud, runs locally. I pay sometimes a large amount of money to receive some guarantees of stability, of features delivered in a timely manner.
That is the kernel. There are lots of applications built on top of the CRM
I'm not talking about that.
infrastructure.
So I'm talking about just CRM application. I'm not talking about Force.com. I'm talking about Salesforce.com. The original CRM application. When they deliver it, do they build it in such a manner, in such software? Because my economics as a consumer of this is I pay an X amount of money, and I expect.
Salesforce has in fact set themselves up as a kernel provider. They have created a platform on which others do this, and they're selling that for profit.
And this is what they do with
a slightly different model.
And this is what they do with Force.com. But I'm not talking about that model. This is more referring to what I asked earlier, like Facebook. This is very similar to what Facebook did. But I'm talking about the actual application that someone pays money to use. And he expects in return to that, for that money, for that license, he expects certain stability, he expects patches, bug fixing, support, I don't know.
What about MySQL?
Okay.
I mean, that's an open source model, but it's a lot.
Yeah, there's a bunch of new NoSQL systems, MongoDB, Couchbase, MySQL, so that are doing it in the same model, a little bit different business model though.
Yeah,
you're not exactly selling it, you're giving it, and then you sell the services or some kind of other licenses which are more advanced.
Yes.
I think we have some kind of an illusion of stability. If you look at operating systems or database, we have this illusion that if you go from version N to version N+1, we have something like a monolithic version transition. But if you look at the list of security-related patches or the stream of cert notices that are related to any database, any CRM, anything that's out there, you will see a completely different picture. So I think that what you have is the big increments and hopefully minimally necessary increments. It's just an illusion of stability that you have. Look at all those patches that you get. Anybody who's worked with a database, with an operating system, and is on the cert list of whichever product it is, you'll see it. Or go into cert and check your favorite quote-unquote stable system. So you have the large cycle and the small cycle as well. It's not that much of a very monolithic system.
But even so, as I said in my second to last slide, I don't claim that this model is appropriate for all forms of development. I think that where you do find it congruent with your business model, you can get enormous benefit by leveraging it, by nurturing it.
Yeah, okay, so that was basically my follow-up question. Given that you have seen this in enterprise companies or in how would you characterize it? And it seems from this discussion, this short discussion, that it's mainly characterized by the business model that is used to deliver or sell or
make money out of the software. A business model that is similar to Facebook or Course.com, for example, may be more appropriate to apply these ideas.
This idea of service-dominant logic.
Yeah.
That you're now making money from selling services rather than selling product.
We see a few occasions where big companies are buying open source projects. They want to dominate the open source. So how would that conflict with the open source trend?
Well,
they are actually trying to close it to their own proprietary.
Yes. Yeah. eBay just did that. If X.com, they bought. Pardon me? Magento, exactly. Thank you. I couldn't think of the name of the company. They bought Magento, and they're taking it from open source to closed source. You can do that, of course, or you can at least, you can never retroactively remove all of the open source versions of Magento, and you don't have to release any improvements from then on. But you then lose all of the benefits of the Metropolis model. You lose all of the benefits of peer production, of the many eyes, of the many contributions. And so there's no one business strategy that's right for all companies. Maybe X.com is going to be right in the end. Maybe not. Time will tell. But I think it's fairly safe to say that they won't get any of the benefits that Magento enjoyed by being open source.
But what about the contributors? They are fools. They did a lot of contributions. They thought it would be open for so long, and
well,
it's closing.
I don't know the license terms under which they were operating, but under most open source licenses, there's nothing stopping them from calling it Magenta and creating a new open source project and continuing to develop that. It's just different than the branch that eBay has taken closed source. Right? There's no constraint on their activities post-sale, whereas there is a constraint on eBay having gone closed source.
Yeah, and to add to this discussion, there are many examples of companies buying open source projects and continuing them in terms of open source, like Google taking VPX and continuing it in open source, or WebKit, things that continue open source because of all these benefits that you mentioned.
Yeah, absolutely. I think that it's clear that open source and open content are not going away. Their influence has been steadily rising in the world of software. And again, I'm not saying that all projects ought to be developed this way or will go this way. I'm saying if your business model aligns with this, then you need to think about developing software differently. You cannot use your old project management software development techniques and expect an open source or open content project to flourish under those models, under that logic.
At the beginning of the talk, you set the guide that every project goes from stable state to a stable that you can't maintain it anymore because it gets more complex and some kind of self-destruction mechanism.
Yes.
This process in the two old system and the Metropolis model, does the Metropolis model have any benefits in this model, or it's running faster to the end?
So it's not that a traditional project could not do this. A traditional project could focus just as heavily on modularity of the kernel and could strictly separate kernel from periphery and enjoy the same benefits that many open source projects have done. The fact is they don't. And that's because they have different incentives, different project structures, different architectural mechanisms in mind. So again, not that they couldn't. Anybody can adopt any set of rules in developing software, but historically they have not. So a completely closed source project has tended to blur the lines between modules, has tended to allow designs to erode, has tended to allow layer bridging and cyclic dependencies and all kinds of shortcuts in the interest of expedience, in the interest of making the next release. And these things, the collective accumulation of these are technical debt, right? They accumulate until they eventually weigh down the project.
They're shanty towns.
They're shanty towns, yeah. Yeah, and so that's just much, much easier to do in a closed source project where you own it all, you have control over it all. And frequently you're driven to do that because of the pressure of meeting deadlines. Open source projects have no deadlines. They have no release dates that they're committed to, by and large. So it's a different set of incentives, which incentivizes different behaviors.
Perhaps the difference is the stress on refactoring. In other words, in what you're describing, together with the constant evolution, is this constant refactoring,
yes,
which when you're in an enterprise and you have limited resources and the pressure is to put out new functionality, the refactoring isn't usually done, and that's why you get the entropy that you get. If we were to stress more refactoring, then that might alleviate to some extent Lehman's observation.
Yeah, I'm actually doing a little bit of analysis now of some open source projects, just trying to determine what the frequency of refactoring is in their JIRA issues, and it seems like it's pretty high, but I don't have the numbers yet.
Yes. I was wondering, I think you mentioned the mapping project.
Yeah.
It looks at dependencies of components.
Yes.
So I was sort of superimposing that on the model, Metropolis model. I was wondering whether it could now be observed that there are certain classes, maybe components that, in addition to different classes, ones that are very reliable, that are usually going into kernel development, and are being shared freely across open source ecosystems. And other ones which are less reliable, which end up in the periphery.
That's an interesting thought. So you think that things may migrate based on their reliability, based on their characteristics?
It's probably emergent and interactive, but there will be components that get much more attention from them.
Yeah, I mean,
so you should be able to partition the space of whatever is out there in terms of components to things that are by nature more reliable than others.
Right. It's certainly the case that from time to time the kernel will swallow up something that had been at the periphery because it's deemed to be a sufficiently universally useful service. I don't know that that judgment is made on the basis of reliability, but so I don't know if if that's a necessary condition or if it simply by force becomes more reliable when it goes into the kernel because it has to, because it has much greater scrutiny. So yeah, I don't know if it's the chicken or the egg.
It could create sort of a two-tier market. The reliable ones and then.
Yes.
I think that when you talk about the kernel, I think when you talk about reliability and the stress on the reliability of the kernel, it's about it should be good enough reliability. There's a difference in what happens in your mapping kernel when it goes wrong, and what are the consequences of that as compared to what happens in lolcats. Lolcats. I can have cheeseburger. So you won't see your favorite cat or dog cartoon for the next 5 minutes.
Right.
Have a mapping API go down, or worse, have the GPS civilian system outage for 5 minutes, and you'll see the impact of that.
Right.
And GPS, for example, is one of those things where you have emergent behavior, you have a very you have an accessible API, and look at everything that's emerged on top of that specific infrastructure that just had the civilian mode open. Today, there are cases where there was a minor outage in London 2 years or 3 years ago, and the tube wouldn't open the doors at the station because they were using GPS to verify that the train is aligned with the platform. Minor glitch.
Yeah, I mean, I did say that sufficient correctness is the norm, and the kernel is typically more reliable than the periphery, but you're right, different projects will have different standards for what acceptable reliability means.
Or any other abilities.
Or any other ability. If you look at something like like Hadoop and the Hadoop distributed file system, that has extremely high reliability requirements because lots of big companies are using it to manage their cloud. But you know, Bill and Ted's excellent open source software may have considerably lower requirements.
When you think in terms of the kernel and the periphery, we could say that these modules or applications that are on the periphery, they are clients of the functionality provided by the kernel.
Yes.
Now, if there are many such models and they are evolving, the evolution of the requirements of these models in the periphery probably will demand some evolution of the kernel itself. Then
Yes.
probably some models will require some kind of functionality that's not currently provided by the kernel.
Yeah, kernels will evolve, for sure.
So there are at least two questions here. What happens when you have different models on the periphery requiring functionality sets that are not compatible or that are contradictory? And another question, how should you prioritize, how define the priority of these different functions that are being required by different models and should be added to the kernel?
Yeah, so from what I've seen in observing open source projects, there's a consensus-based process for determining what goes into the kernel, what requirements are addressed in what order. I have not seen a set of principles. What I've seen is an active discussion, usually over their mailing list or their JIRA, which in most cases will result in a consensus opinion, and then people move to actually develop that, usually the ones who championed the idea. So again, there's no notion of higher authority, there's no notion of overall goal-directed behavior, I would say. It's all opportunistic, and it's all crowdsourced. It's the wisdom of the crowds at work.
So do you think there is a risk of starvation in the case that some module in the periphery requires some functionality that is not being implemented by the kernel?
Absolutely. Yep. I mean, if the kernel doesn't value the particular function or feature that you believe you depend on, you won't get it. Yeah. And that's, again, the wisdom of the crowds. Where, you know, maybe you wouldn't think it's wisdom in that case, but...
Yeah. We have faced such problem in a company I have worked in the past, in which we had several products being developed by this company, and we had an infrastructure team which would provide all the common infrastructure, all the shared infrastructure to these several products. And because this infrastructure team didn't have enough resources, what happened is that the common infrastructure became branched. You know, the teams developing the products started to make their own branches of the...
That was the next thing I was going to say is, if you needed some change to the kernel, you could just go and do it yourself, and then two things would happen. The kernel team would accept your patch, or they wouldn't. If they didn't accept your patch, you were free to fork the kernel and create your own branch on the open source tree, which then it would be your responsibility for incorporating all future changes to. In fact, this is what Yahoo did for quite some time with HDFS, and finally they came back to the main trunk. They decided that the cost of maintaining that branch was too high.
We were talking, in the last minute, we were talking not about large companies. How would you counter the argument this wave of individuals or small-scale groups creating value peters out once the level of service you expect from an application becomes higher and higher?
Sorry, peters out once what?
Today I can write an Android application and put it at an acceptable level. I have some buttons and I can slide a little, and that's all I can build in 2 months, and that's okay.
Yeah.
In 10 years from now, the Android interface will have evolved, it will become more complex. We expect from an application that it has some features which are harder to program for a small group. So in the end it will be companies, mid-scale companies, who create this value. Like a Salesforce application today, there are very few individuals who write that, and there are small companies who build a specific solution.
Yeah, I guess I would argue with your premise, though. I think that over time, these platforms have become easier to build upon because you get more productivity tools. I don't think they've become harder to build upon, even if the application itself, or so the application platform itself becomes more complex. Someone's going to come along and put another layer on top of that to provide a more usable interface. So so far I haven't seen evidence for that path that you're worried about.
Microsoft is doing some tests in the open source arena. They take some sub-projects and try to make them open source, some with full users control and some with their own control. The idea of a profit company trying to incorporate open source in their product. Your thoughts about it?
So, a couple things. One is, if the open source company wants to do this because they want to get more productivity.
Closed source company.
Sorry, a closed source company. They want to open source some of their products because they believe it will get them more productivity. It will only succeed to the extent that they can attract a crowd of contributors, and like I said before, in terms of the management structure, give those contributors a feeling of control, of belonging, of being in a kind of win-win situation, that they get something out of it. People that develop open source software are doing it for essentially the hedonic pleasure of developing it. So it's very difficult to motivate them or to threaten them either way, you know, to get them to do something or to get them to not do something. What you have to try and do is, well, motivate, to lead them, to inspire them. And that's a different way of managing than companies are traditionally used to.
Did you research any of those projects from Microsoft, like the MVC and some other? The entity framework, the MVC products, which now they announce as more or less open source, very close to the Metropolis.
So I haven't followed any of those, but the other thing that I was going to say for the closed source company, the second half of the answer to that question, is that you have to worry about how you manage the licensing dependencies between the open and the closed source parts of your product. And you have to be very careful that you don't contaminate the closed source with the open source licenses. So depending on which license model you choose, and depending on how closely the closed and open source products are linked, you may inadvertently be required to open up more of your code base than you intended. Right? There was the famous example of Linksys a few years ago having to open source their router code for that reason. So it does bring up an additional complication for a company that's trying to play on both sides of the fence at the same time.
Did it prove the reference?
It did. And they sold 1 million of them, but they weren't happy.
And we are constantly talking about contributing code, and I think Paul, the question by my colleague was should we talk also for contributed architecture and solutions and designs maybe that is, in my eyes at least, much more valuable than the contributing the code itself, because for commercial companies like Microsoft, ourselves and others, I think there is a huge community. There are people are contributing ideas, going back and forth, becoming consultants, turning to the company as employees. So I think it's much more valuable than contributing the lines of code. Enough coders to write them.
Yeah. So again, this may change over time as it evolves and matures. But right now, every architect that I've seen in open source projects does not call himself an architect. There's no such label in, I can't think of any open source project where somebody calls himself an architect. So code is king. Even though they are doing things that to the outside observer looks like architecture, they haven't really employed that language. And so somebody who just did architecture and didn't contribute code probably would never become a committer. And that also only works if the kernel is kept small, because otherwise you can't possibly keep all of it in your head, which is what happens when you don't have architecture documentation. There's no other. The truth is in the code.
Sure. My question was more for, like, we can produce the kernel and keep it closed source, but I think the much bigger value is by asking the community and getting the ideas from the community. What should we provide? To which direction should we go with this kernel? To let the community to build things on top of it, and maybe to use it in very innovative ways that we even cannot think about.
So
maybe this somewhere different from the pure code model of exchange of the code, this kernel developers and users model, and mainly about exchanging ideas and solutions.
Ideas are changed. You know, people are talking to one another. The wiki, even trying to give samples of code of ideas. It's happening in open source systems.
Yeah.
But they don't call it architecture. That you know.
Yeah, I guess you're right. I mean, they already have those kinds of discussions now.
I think that a lot of this, we talked about technology mostly, but I think that the major power where it either falls or rises or scales up has to do with the social infrastructure. What values are underlying there? Who are the key people there? And this, I think, is the difference between ending up with an abandoned shantytown or something that keeps getting patched, and something that keeps getting refactored in the right way. If you use the same, you had a few of those cloverleaf interchanges, and it's not so easy to change your kernel from using traffic circles to using loops, especially if you're talking about a ubiquitous system, always on. Right. And if you didn't plan your APIs well in advance, stop. Yeah. Even if you change the kernel, you're still restricted by the API, or you drop one generation out of the loop.
Yeah, yeah. So you
carry two kernels.
Yeah, yeah. So yeah, evolution is hard, and that's true in closed source and open source systems, because legacy is a burden. The other point that you bring up, which is a good one, is that the leadership qualities of the architect or architects are often the key difference maker between a metropolis and a shantytown, as you say.
Mm-hmm. And if you look at Star Trek, look at Gene Roddenberry. He's labeled as the creator, but after the original series, and even during the original series, there were very few episodes that came from him. But years after that, people would go to him with a script or with a script proposal or in an episode outline and would say, does this work? And it's about
still the thought
maintaining,
leader.
yes, about looking at a set of values and using a consistent set of values that would keep it steering in the appropriate direction.
Yeah, and I think you see, you know, the Jimmy Waleses and the Linus Torvalds and so forth, these superstars of open source and open content exerting that kind of influence.
Thank you very much.
Thank you.